Well, let's talk about solving systems of linear equations graphically. Here we go. Name, date, title. For a warm-up, whenever we start talking about solving systems of equations, I like to talk about what is a system of equations, why is it useful, and this is my favorite warm-up question, so here it goes. Netflix costs $10 a month for all movies in their library. Redbox offers rentals for $1.50 per movie. Who should order Netflix and who should order Redbox? So, hopefully you can see that we can draw two linear equations from this. Now, if I ask you what are the two variables in these decision-making processes, I guess, what would they be? The first one, the independent variable, the thing that you're going to change most often is going to be the number of movies you watch. And the second one would be the total price you pay per month. So the number of movies per month and the price you pay per month. For Netflix, it doesn't matter how many movies you watch. 0 times the number of movies you watch plus $10. Because you're just going to order Netflix, you're just going to pay $10. And then no matter how many movies you watch, you're just going to have paid that $10. For Redbox, there's no startup fee, so there is no Y-intercept. You don't have to pay anything if you don't watch any movies. What am I doing? But you do have to pay $1.50 every time you watch or order another movie. So we'll put 1.5x. So that's Redbox, and that's Netflix. And so we see we have two linear equations here, and we can plot them both on the coordinate plane, and then we'll talk about them a little bit more, and it'll help us to answer our question, who should order which. So let's make each of these worth 2 so that we can get all the way up to 10 and it won't be at the very top. So that's my y scale. So I know that Netflix is, if I drew an XY chart, or if I just understood what's going on and thought about it for a while, I'd be like, the X's don't matter. No matter how many movies you watch, you're always just going to pay $10. So no matter what X is, Y is always 10, which means we have a horizontal line. So this is our Netflix line right there. Now, next question says this. Well, what would it be for Redbox? What's that line in that equation going to look like? And if we do an XY chart over here, we're going to see that, well, if x is 0, y is 0, and so the y-intercept is 0. And that makes sense because we have no b value if we're thinking of this as slope-intercept form, which it is. If you get 1, you're going to pay $1.50. 2 movies, $3. 6 movies, it would be $9. And so let's plot this one as well. So 0, 0, but then it goes up to 1, 1.5, 2, 3, 6, 9, 5, 6. Is that 6, 9? Yeah. And we have a linear equation for that as well. Now, why is this useful? Why would we ever talk about two equations at the same time? And I'll be honest with you, it does have a lot of applications, specifically if you're thinking about kind of business decisions. And do we watch enough movies to warrant ordering Netflix, or should we do Redbox? And hopefully you can see that, well, if our y-axis is the total cost, then we want to be as low as possible. We want to have a low total cost each month. So in which case does it make sense for us to be Netflix? In which case does it make sense for us to be Redbox? It's really a question of when is the Redbox line lower and when is the Netflix line lower. And if you're watching fewer movies, just between 0 and 6, you're probably going to want to use Redbox because you're paying less. But as soon as you start watching 7, 8, 9, 10 more than that movies a month, you're going to want to order Netflix because that's when the Redbox price soars above, and we want to keep that low, consistent $10 Netflix price. So this is the whole idea. Solving systems is we're finding this point where two equations cross, or where they have the same x value and the same y value at the same time. So in this case, it'd be what number of movies will cost the same either way, which is the decision where it really doesn't matter. You're going to pay the same for the same number of movies. So this is what we're working with. Let's get into some practice problems. But first, some notes. Every function has an infinite number of solutions. We already know that. Most systems of two functions have one solution that makes both true simultaneously. So we can think of that as if we're drawing two lines. Yes, that line includes all the pairs of xy values that make that one line true. But if we think about most lines on the coordinate plane, they're going to cross once. That point where they cross is the only time that the same xy pair makes both true. So they have one solution that makes both true simultaneously, an xy pair. We can discover that solution to a system of equations by graphing both and seeing where they intersect. The challenge questions I want you to consider, I'll tell you when we do practice problems, are when would a system have no solutions, using what I've already described and what you already know, and when would it have an infinite number of solutions, a system? When would the system of two linear equations have no solutions? When would it have an infinite number? So think about those, keep them in the back of your mind. I'll reveal them later. But first, let's get to some practice problems. This says y plus 13 equals negative 3 times the quantity of x minus 8. That's one equation, and our second equation is y equals 2x minus 9. What I'm going to do here is I'm going to use what I know about these different types of linear equations. This first one, I can notice that this is in point slope form, so I can tell you right away that the slope is negative 3. There's the slope. And the point that is on here would be 8, negative 13. So I'm going to use that, and that's going to help me to solve this. The other thing I can tell you is that this is slope-intercept form. So I know that the slope is 2, and the y-intercept is 0, negative 9. So we should be able to plot both of these. So let's see how it goes. Let's see where they intersect. For this first one, I know that we're going to have to go pretty low. Let's make our y scale negative 2. So I know that if I go 8 to the right, I go 13 down. So 8 to the right, 13 down would be 6 down and half another. So if each of those was worth 2, then going down 6 got me to negative 12. Another halfway would get me negative 13. A slope of negative 3 means I'll go down 3 every time I go to the right, but it means I'll go up 3 every time I go to the left. So that should be another point. And that should be another point. Now I'm going up 3, but I'm using my scale, so hopefully that you can see where that comes from. And y equals 2x minus 9. First I'll just plot this y-intercept of negative 2, 4, 6, 8, 9. And this one goes up 2 every time I go to the right. Up 2, up 2. I hope this works out neatly. Up 2. And it looks like that's where they're going to cross. I'm going to double check that in just a second, but we can solve this graphically just by plotting some points of each equation and seeing what coordinate pair makes them both true at the same time. It looks like this is our point 1, 2, 3, 4, negative 1. And I'm going to plug this in. If it is in fact the solution, then I can plug it into both equations and it would make them true. So let's see. If I put in 4 in for y, is 4 equal to negative 1 times 2? If I put in negative 1 for y, is negative 1 equal to 2 times 4, 8 minus 9? It is. If I put negative 1 in for x, oh my goodness, negative 1 in for y, negative 1 plus 13 is 12. Is 12 equal to negative 3 times 4 minus 8? 4 minus 8 is negative 4. Negative 4 times negative 3 becomes positive 12. Is 12 equal to 12? It is. So this is our solution. It makes both of those true. It's the only point, the only xy combination that makes both true. So there's our solution. We found it just by drawing the graph and seeing where they intersected. This next one says, altogether, 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher leaves 2 cups of water. How many cups of water can each pitcher hold? Now you might be thinking, this sounds logically crazy and weird and confusing, but let's just try and put it into some linear equations that we can plot. Let's call our small pitchers x, and let's call our large pitcher y. And in that case, 2 small pitchers and 1 large pitcher, so x times 2, 2 small pitchers plus 1 large pitcher can hold 8 cups of water. 1 large pitcher, a y, minus 1 small pitcher, minus an x, leaves 2 cups of water. We could graph this to solve. So I'm going to transform this equation just by adding x to both sides, and I would then have y equals x plus 2. And I can transform this one by isolating y by subtracting 2x. So this would be y equals negative 2x plus 8. Now let's graph both of these. I can see their y-intercepts. Those are the b terms. So this first one, I'll go all the way up to 8 and say every time I go to the right, my slope is negative 2. I need to move down 2. So plot at a couple of points. There we go. This next one, slope or y-intercept of 2. And then it just goes up 1 every time I go to the right. Well, I already found my solution just by graphing. Now you're saying to yourself, but what's this answer going to tell us? Well, the answer is going to tell me the size of both of these pictures. So if I know that the solution lies at 2, 4, if the solution is at 2, 4, and I said y was the large and x was the small, so the small holds 2 cups and the large holds 4. So using systems of linear equations can help you solve a variety of different problems. So in this one we found out kind of a confusing little riddle about pitchers and how much they can hold. So let's make sure this makes sense. 2 small pitchers and 1 large. So 2 times 2 is 4 plus 4 can hold 8. Good. And 1 large minus a small, 4 minus 2 equals 2. Okay, we found the exact sizes using the coordinate plane by graphing a system. So hopefully that one made a little bit of sense. I'm going to leave you with some to work on your own. The first one just says solve the system by graphing y equals 2x minus 3 and y equals negative 5x plus 20. You might have to use a different scale. Second one says solve this one by graphing, and then not just in slope-intercept form. This is y minus 6 equals negative 2x plus 7 times the quantity of x plus 7. Second one says 4x minus y equals negative 4. Now the challenge questions, I said, when will a system of linear equations have no solutions? And we talked about how it's the intersection point. So when will 2 linear equations not intersect? And it's when they're parallel. And when would it have an infinite number of solutions? Well, when will it intersect an infinite number of times? Not when they're parallel and not when they're perpendicular, but when it's 2 ways of writing the exact same equation. So those are our 2 answers to the challenge questions. Thanks for paying attention, and I will catch you later.